What if the biggest threat to the AI revolution isn't a lack of smart chips, but a 100-year-old problem?
Right, like basic electricity and heat.
Exactly. Welcome back to another deep dive. Today, we are looking at the company trying to stop the tech world from literally melting down.
Yeah, which is not an exaggeration at all.
It really isn't. I mean, whether you are following the latest hyperscaler data center builds, tracking the EV market, or just looking at global power infrastructure, the management of raw electrical power is, the ultimate bottleneck right now.
It's the physical limit to all this digital growth.
So our mission today is to unpack onsemi, also known as onsemiconductor, to see how they are engineering their way through that exact bottleneck.
And we have an incredibly data-rich stack of materials to get through today.
Oh yeah, a lot of numbers.
Definitely. We're dissecting their Q1 2026 earnings call transcript featuring CEO Hussein El-Khoury and CFO Thad Trent. We're cross-referencing that with their financial press release and digging into the specific technical roadmaps from their Q1 investor presentation.
Which gives us a really clear picture of how the hardware layer of the market is adapting to some massive structural shifts.
Completely.
But before we get into the heavy analysis, just a quick reminder for you listening, all the information and analysis we chat about here is just to help you understand the market better, and it is definitely not investment advice.
Right. Always important to know.
Yeah, investing involves risks. So before entering the market, please make sure to do your own homework or consult a professional financial advisor.
Absolutely.
Okay, let's unpack this. I want to start with the hard numbers because the semiconductor cycle has been, well, notoriously brutal over the last year.
It's been a rough ride for a lot of players, yeah.
Right? But looking at Q1 2026, management is making a pretty bold claim that they have essentially found the bottom of the cycle.
They're definitely putting that narrative front and center.
All right.
If we look at the headline numbers for Q1, onsemi reported revenue of $1.513 billion. And that represents a 1% decline sequentially from the previous quarter, but it is actually up 5% year over year. And it comfortably beat the midpoint of their own guidance.
Beating guidance is obviously the easiest way to keep Wall Street happy.
Oh, for sure.
But when I look at the profitability metrics, there is this massive discrepancy that jumped out at me.
The GAAP versus non-GAAP numbers.
Exactly. Their GAAP diluted loss per share was 8 cents, but then they're pointing investors toward their non-GAAP diluted earnings per share, which is a profit of 64 cents.
That's a huge swing.
Right. I always get skeptical when a company loses money on paper but then asks us to look at a highly profitable, adjusted number. What is driving that 72-cent swing?
Well, it is a perfectly valid reason to be skeptical. But in this case, the mechanics of that swing are fully transparent in the financials.
Okay, so what's the actual cause?
The gap is primarily driven by roughly $50 million in restructuring costs and planned non-core exits. They are intentionally taking a financial hit this quarter to walk away from legacy, low-margin analog chips.
Wait, so they are willingly sacrificing top-line revenue volume?
Basically, yes.
It feels a bit like a coffee shop realizing that their giant, complicated breakfast sandwiches take way too long to make and barely turn a profit.
Right.
So they just throw out the sandwich presses to make more room for the high-margin espresso machines.
That's a great way to think about it. The underlying logic is similar, but the scale is obviously vastly different. They are shrinking their legacy footprint to clear highly valuable factory floor space.
Floor space for what, exactly?
For their next generation silicon carbide and advanced power modules. By taking the write-down now, they clean up their product mix.
Okay, that makes sense. Short-term pain for long-term gain.
Exactly. And the clearest signal that this strategy is actually working is a specific metric the CFO highlighted. Year over year, their non-GAAP operating income growth outpaced their revenue growth by a factor of 2.
Wow. Operating income growing twice as fast as revenue.
It's a huge indicator.
That tells me they didn't just sell a few more chips. They fundamentally lowered the cost to produce every single unit. Or the new mix of products is just, commanding vastly superior margins.
It's actually both. Both are happening simultaneously, driven by an internal initiative they call FabRight.
FabRight. I like the branding.
Yeah, and this is how we get to the mechanics of their gross margin. Even in what they are calling the bottom of a cycle, their non-GAAP gross margin expanded for the third consecutive quarter, hitting 38.5%.
In a down cycle, that's impressive.
Right. That is up 32 basis points sequentially. FabRight is their strategy of ruthlessly optimizing their manufacturing network. They're divesting subscale or inefficient plants and consolidating production into their most advanced facilities.
Okay, but I want to push back on one of the manufacturing metrics they mentioned, though.
Go for it.
The earnings call noted their manufacturing utilization sat at 77% for the quarter.
Yes, 77%.
So that means nearly a quarter of their multi-billion-dollar factory capacity is just sitting idle. In a highly capital-intensive business like semiconductors, isn't an empty factory just burning cash?
Normally, yes, you'd think so. The fixed depreciation costs of a semiconductor fab are staggering.
Right.
But you have to view that 77% in the context of their historical cycles and their inventory strategy. If you run the machines at 100% just to absorb the fixed costs, what happens?
You end up making stuff no one is buying.
Exactly. You build a mountain of inventory that nobody wants, which eventually leads to massive write-downs later. They're holding at 77% to maintain strict inventory control.
Ah, okay. Better to have idle machines than warehouses full of useless chips.
Precisely. Furthermore, CFO Thad Trent outlined a critical rule of thumb for their operating model.
Yeah.
He noted that every single point of utilization improvement equals about 25 to 30 basis points of gross margin improvement.
Let me do the math on that. So the moment demand ticks up and they turn those idle machines back on, moving from 77% to, say, 80% utilization, that immediately drops almost a full percentage point of pure profit to the bottom line without them having to make any new capital investments.
Exactly. They just flip the switch. And their capital allocation strategy shows they are highly confident in that future cash generation.
How so?
Well, during Q1, they returned $346 million to shareholders via stock repurchases at an average price of 60.54 cents.
346 million.
Yeah, and that 346 million represented roughly 160% of their free cash flow for the quarter.
Wait, they spent more on buybacks than the actual cash they generated?
They did. When management spends more than their free cash flow to buy back shares, they're essentially signaling to the market that they view their own equity as undervalued relative to the cash they know those factories are going to print down the road.
All right, so the manufacturing footprint is leaned out, margins are expanding, and they are buying back stock. But let's get to the actual products.
Let's do it.
Because high margins only exist if you are building something the market is, desperate for. And right now, the market is completely desperate for AI data center infrastructure.
It really is. And the growth in their AI segment is staggering. Their AI data center revenue grew over 30% quarter over quarter.
Just in one quarter.
Yes, and it doubled year over year. Plus, CEO Hassan El-Khoury noted they expect this specific revenue stream to double again in 2026 compared to 2025.
Okay, everyone obsesses over the GPU architectures from companies like NVIDIA or AMD. We always talk about processing power and memory bandwidth.
Which is the glamorous part of the tech, sure.
Right. But those GPUs are essentially giant energy vacuums. You can't just plug a rack of next-gen AI servers into a standard industrial power feed.
You certainly cannot. And this is where onsemi really dominates with what they call the power tree.
The power tree. Okay, explain that for us.
So the raw power entering a data center has to be stepped down, converted, and managed with absolute precision before it ever touches a processor. onsemi supplies the components across that entire journey.
The whole way down?
Yeah. They handle the high voltage conversion at the grid level, the rack level power distribution, all the way down to the highly sophisticated intelligent power stages that sit mere millimeters away from the GPU.
Just to deliver that precise voltage.
Exactly.
Let me try to visualize this for everyone listening. It sounds a bit like a city's water supply.
Okay, I like where this is going.
You have the massive high-pressure pipes coming from the reservoir, that's the utility grid. Then you have the neighborhood pumping stations, which would be the server racks.
Right.
And finally, the highly filtered, precise tack right at the kitchen sink, which is the point of load at the actual AI chip. So onsemi is basically building the valves and regulators for every single stage.
That works perfectly conceptually, but let's add the physics to that analogy.
Hit me.
Imagine if every time the water moved from a larger pipe to a smaller one, 10% of the water just instantly boiled into steam.
That would be a terrible plumbing system.
It would be. But in electrical terms, that is called conversion loss, and it manifests as pure heat. The higher the power density of these new AI racks, the more power is lost during conversion.
And the more heat is generated.
Yes, which then requires even more power to run the cooling systems to bring the temperature back down.
Which creates this vicious cycle of massive energy consumption.
Exactly.
And this ties directly into the policy shifts we are seeing right now. Policymakers in the U.S. are starting to demand significant transparency regarding data center energy usage because hyperscalers are drawing so much power they are literally destabilizing local grids.
It's becoming a major civic issue. Looking objectively at that regulatory trend, hyperscalers are under immense pressure to improve their efficiency.
They have to do more with less power.
Right. And onsemi's high-density silicon and silicon carbide solutions are specifically engineered to drastically reduce that power loss from the grid down to the processor.
So they're directly solving the heat and efficiency problem that the data center operators are being pressured to fix.
Exactly. They are in the perfect position.
So they are riding this incredible halo effect from AI, but they are solving the heat and power loss problem in stationary data centers.
Right. Stationary.
What happens when you have to put that same massive power draw on 4 wheels and a battery? The broader narrative around the EV market lately has been, well, incredibly bumpy, to say the least.
Bumpy is a polite word for it. It has been a really challenging macro environment for automotive, which makes onsemi's Q1 performance stand out even more.
Oh, really? How did they do?
Their automotive revenue came in at $797 million. Now, while that was flat sequentially, it was actually up nearly 5% year over year.
Up 5% in this environment.
Yeah, and that is a major inflection point because it reverses 7 consecutive quarters of decline in their auto segment.
Wow. Reversing a 7-quarter slide is a big deal. What is the catalyst breaking that downward trend?
A significant driver is the dynamics of the China EV market. Just looking at the raw data from the reports, the Chinese domestic passenger vehicle market actually declined by 6% in the first quarter.
Okay, down 6%.
However, their specific EV programs continue to heavily outperform, driven by very aggressive export growth. And the standout metric from the earnings call was that onsemi claims a massive 55% market share of the silicon carbide components deployed in the new EV models showcased at the April 2026 Beijing Auto Show.
Wait, 55%? Capturing more than half the market share at a major international auto show is dominant.
It's massive. And the call also highlighted their expanding collaborations with companies like Geely and NIO for next-generation 900-volt platforms.
Okay, let's break down the mechanics here. Why is the industry moving to 900-volt architectures, and why is silicon carbide required? I mean, doesn't traditional silicon work just fine?
Traditional silicon literally hits a physical wall at those voltages. When you step an EV architecture up to 800 or 900 volts, you completely change the thermodynamics of the vehicle.
So it just melts.
Basically, yes. But silicon carbide is what's called a wide band gap material. Because of how the electrons are structured at an atomic level, it can handle much higher voltages, it can switch at vastly higher frequencies, and it dissipates thermal load much more effectively than standard silicon.
Okay, so it can handle the stress without melting, but why go to 900 volts in the first place? Why not just stick to lower voltages?
Because higher voltage allows for much faster flash charging. But more importantly, it means you can push the exact same amount of total power through the system using significantly less electrical current.
Okay, and less current means what?
Less current means less heat, which allows automakers to use much thinner, lighter wiring throughout the entire vehicle.
Ah, so thinner wiring saves copper.
Yeah.
But does the everyday consumer actually care about the gauge of the wire hiding in their chassis?
They care deeply, whether they know it or not.
Why?
Because stripping 100 pounds of heavy copper wiring out of a vehicle directly translates to increased driving range on a single charge.
Oh, less weight means more miles. That makes perfect sense.
Exactly.
Yeah.
And that brings us to the other massive automotive shift the call covered, which is the Trio platform and zonal architectures.
Right, Trio. Because the EV transition isn't just swapping a gas tank for a battery, it's a complete redesign of the car's nervous system.
Completely.
I hear this term zonal architecture thrown around a lot. Is that like upgrading to a smart home where every single light switch and sensor just talks wirelessly to a central Wi-Fi router?
It's close, but relying on wireless data transmission is far too risky for critical systems like a car's brakes or steering. You don't want your brakes buffering.
Yeah, that would be terrifying.
So it's more like upgrading a home where instead of every single light switch having a dedicated copper wire running all the way down to a giant breaker box in the basement.
Which is how old cars work.
Right. Instead of that, each room has its own localized, hardwired control hub.
Ah, so you have a front left zone, a rear right zone, and all the sensors in that physical area just plug into a local controller.
Precisely. That local zonal controller processes the basic inputs instantly and then communicates with the central car computer using a single high-speed data cable.
That saves so much wire.
It does. And they are specifically utilizing the 10-base T1S Ethernet solutions that onsemi provides via their Trio platform. This allows multiple sensors to communicate over a single, short pair of wires without data collisions.
Which completely eliminates the massive, heavy, centralized wiring harnesses of legacy vehicles.
Exactly. It reduces weight, it dramatically simplifies the software integration, and it lowers the bill of materials for the automaker.
That is a really potent combination. They are providing the high-voltage muscle with silicon carbide and the high-speed nervous system with the Trio Ethernet platform.
It's a dual-pronged approach to dominating EV hardware.
We have spent a lot of time on the huge wins in Q1 with AI and auto, but let's look at their guidance. What does the rest of 2026 hold? And we also need to touch on the industrial segment, which sometimes gets lost in the shadow of AI.
Yeah, industrial is important. For Q2 2026 guidance, management expects revenue to land between $1.535 billion and $1.635 billion.
Okay.
With non-GAAP gross margins projected to expand again, targeting between 38.0% and 40.0%. And a key part of hitting those numbers relies on the stabilization of their industrial segment, which pulled in $417 million in Q1.
Gotcha.
They are projecting mid-single-digit sequential growth there.
Now, industrial encompasses a lot of different things. Were there any specific bright spots driving that growth?
The real standout is utility-scale energy storage and solar. They are actually modeling a 40% year-over-year growth in that specific sector alone.
40%, that's huge.
It is. They specifically highlighted a new design win with Sending Electric to power massive 430-kilowatt liquid-cooled energy storage systems.
A 430-kilowatt inverter is an absolute beast. But wait, why does a solar storage system need liquid cooling? Are they generating that much heat?
They are, because the underlying physics are remarkably similar to the AI data center problem we discussed earlier.
Conversion loss again.
Exactly. When you are taking massive amounts of DC power generated by a solar farm and converting it to AC power for the utility grid, the conversion loss generates extreme heat. By using onsemi's advanced power modules combined with a liquid cooling system, they can pack a tremendous amount of conversion capacity into a much smaller physical footprint without the whole thing overheating.
Man, it really all comes back to managing heat and power density, doesn't it?
It's the universal problem of the decade.
Okay, the technology roadmap looks incredibly solid, but no earnings call is entirely devoid of risks. What are the macro headwinds keeping the CFO awake at night right now?
The primary headwind is definitely supply chain inflation. The CFO was very transparent that their input costs, the raw materials, the specialty gases, the energy required to run the fabs, all of those are rising.
And currently, those higher costs are just hitting their P&L.
Right. They haven't yet passed them on to their customers.
Well, if they are absorbing the inflation, that threatens the very gross margin expansion they've been fighting so hard for. How do they plan to pass those costs along without alienating these massive auto and tech clients?
They are relying on what they term surgical pricing adjustments.
Surgical pricing, what does that mean in practice?
It means they aren't going to just issue a blanket 5% price hike across their entire catalog.
Yeah.
Instead, they analyze the supply and demand mechanics of individual product lines.
Okay.
So if a specific advanced silicon carbide module is highly constrained and absolutely critical to a customer's roadmap, onsemi will surgically increase the price on that specific component later in the year to offset the broader inflationary pressures.
This seems like it requires a very delicate touch to protect margins while maintaining long-term partnerships.
It really does. It's a balancing act.
Speaking of protecting margins and cash, I was really struck by their capital expenditure strategy for the rest of the year.
Oh, the CapEx numbers are fascinating.
Right. They are keeping CapEx incredibly low in the mid-single-digit percentage of revenue. If they are seeing 40% growth in solar and 100% growth in AI, why aren't they breaking ground on new factories right now?
Because the heavy lifting is already done. Management emphasized that they spent heavily over the last 3 years to build out the necessary capacity for technologies like Trio and silicon carbide.
Ah, right. It ties back to that 77% utilization rate from earlier.
Exactly. They are currently sitting on enough latent capacity to handle 25% to 30% more revenue before they even have to consider expanding their physical footprint.
That is massive operating leverage. Every new dollar of revenue over their fixed cost threshold just drops beautifully to the bottom line because the concrete is already poured and the machines are already installed.
Which brings us full circle to why they are so confident in buying back their own stock. They see the demand curve rising to meet the capacity they've already paid for.
Wow. This has been an incredible journey through the power grid of the future. Let's do a quick recap of the core takeaways from this deep dive into onsemi's Q1.
Sounds good.
Number 1. The financials show a fundamentally leaner operation. Through their FabRight initiative, they have survived the bottom of the semiconductor cycle by walking away from low-margin legacy products, resulting in expanding gross margins and massive operating leverage.
Number 2. AI data centers are providing explosive triple-digit growth. As hyperscalers face regulatory pressure over energy consumption, onsemi is supplying the critical power tree hardware to reduce conversion loss and heat.
Perfect. Number 3. Automotive is officially stabilizing. After a long slump, they are back to growth, driven by their dominant 55% market share in silicon carbide for new EVs in China, the shift to 900-volt architectures, and the copper-saving trio zonal platforms.
And number 4. The future outlook is highly positive with expected margin expansion in Q2, aided by massive growth in liquid-cooled solar infrastructure. However, the execution risk lies entirely in how well they can navigate supply chain inflation through that surgical pricing we talked about.
It is really a textbook example of a company intentionally shrinking its footprint in older technologies to become a highly specialized powerhouse in the exact sectors where the future economy is desperate for hardware.
It really is.
And for you listening, whether you are analyzing a portfolio or just trying to make sense of a world that is increasingly dominated by electricity-hungry AI algorithms and EVs, understanding this foundational hardware layer is vital. Software might eat the world, but it needs a massive amount of highly regulated electricity to do it.
Which leaves us with a final thought to ponder. We are constantly inundated with news about the race for the most sophisticated AI algorithms, the most advanced logical architectures, or, the perfect EV battery chemistry. But looking at the sheer desperation for onsemi's products across all these sectors, it begs a question. What if the true bottleneck for the future of human technology isn't computational limits or software at all?
What if it's not the smarts?
Exactly. What if the absolute speed limit on our innovation is just the simple, unglamorous physics of how we route and manage raw electrical power without melting the system down?
The ultimate speed limit on the future might just be heat and voltage. That is a fascinating concept to chew on. Thank you so much for joining us on this deep dive into the invisible backbone of our tech. Stay curious, keep exploring, and we will catch you on the next one.